Hello everyone. Today let's go over a premium medium question that I just solved on my own. So I actually struggled with this quite a bit until today. I was able to play around with it and notice something that I didn't need, and that got over the memory limit exceeded error, so I'm pretty happy about that. So let's review it. This one is called Brightest Position on Street. It is a prefix sum question using the line sweep algorithm. So if you know that, then it's not too hard. So let's go ahead and read it. So basically you're given a matrix and you want to return an integer. And the thing with the matrix is that the first 0th index of each sublist is the starting position, and then the 2 is basically how far it sweeps in both directions. So if you have -3, your range would be -5 and -1, right? Because it sweeps 2 to the left and 2 to the right as well. So 2 to the left of -3 is -5, 2 to the right of -3 is -1. And you would do that for everyone. So for 1, if you want to sweep 2, you would get the range of -1 and 3, because 1 minus 2 is -1 and 1 plus 2 is 3. So you do that for all the 0th index elements. And what we're going to do is we're going to keep it inside of a dictionary. And you'll see why in a second. So let's iterate over L, and let's call this low is L0, which is the -3, minus L1. So that gives you -5. -3 minus 2 is -5. The high is L0 plus L1. So that would give you -1, because -3 plus 2 is -1. So now let's print low and high to make sure our interval is correct. So cool. So it's supposed to be minus, sorry, it made a typo. Okay, so we have our intervals. Now what we want to do is to basically record the fact that from -5 to -1, we're going to increase by 2, right? But how do we do this efficiently? How do you update a subarray quickly without iterating over every single element and adding 2? Well, as we said with the line sweep, you do 2, 0, 0, and then -2 right after it ends, because if you accumulate this, then you get everything sum up to this point is 2, everything sum up to this point is 2, and then 0, because 2 minus 2 is 0. So that is the quick way to do it, which is known as the line sweep algorithm. And so now, instead of doing this, how about let's keep it inside of the dictionary. So d low plus equals to 1, and then if high plus 1, or d high plus 1 minus equal to 1, because every time we do this, we're lighting it up by 1, right? So let's print the dictionary. So integer, so now we got -5, 0, 0, right? But -1 is 1. So we know that the range is going to be -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, right? So that's what it gives us. So now the challenge is, how do we find the total number of times we have incremented this range? Well, we use the line sweep algorithm too. So first, let's try to sort this. D equals dict sorted d.items. Key equals lambda x0, and that just sorts the dictionary by the keys from smallest to greatest. So we have this nice line, and then if you get the maximum and the minimum, you'll see that the range is -5 to 7. So my original mistake was having to create this, which you actually don't, because what they're going to do is they just want you to identify the position with the brightest. So it's going to be 1 in this case, because the biggest value of any key is 1. And then out of the ones, which is the biggest value, you want to return the smallest one. So in this case, let's see here. So this is supposed to be 1. So it's actually the biggest one, it seems like, not the smallest one. So because -1 is bigger than -5, and both have the biggest values that you can find. Here, -1 has the biggest, it's the only one with the biggest values out of all the values of all the keys in the dictionary.
So now what we can do is just iterate over the dictionary. Well, let's say biggest is max d.values. So we're looking for that 1. This description is a little off. We're looking for that 1. And then for if dk is equal to biggest, right, the value of the current key is equal to the biggest, then we know it could be a possible answer. So result is flow of negative infinity because we're looking to maximize that. So result equals max of result in k, which is the current key. So we're going to see -5. We're going to see -1, and -1 is bigger than -5. So at the end, we can just return -1, I think. So, okay, this is not correct. Okay.
So let's see what's going on here. Let's print the biggest. So the biggest is 2. Which elements have 2 in them? Only this, but we want 1. Oh, so brightest position. Second street lights up area from this to this. Position -1 has a brightness of 2. So it looks like we didn't do that correctly. It's supposed to be 2. So this is the problem because now it looks like what we're supposed to do is 1. And then if you accumulate, then it's 2, and then it's 2, and then it's 1, and then it's 0. Right? So now we have to do h equals list iter tools dot accumulate d dot values. Let's print h. So now we can look for the biggest one in here, and then what is corresponding to the biggest one? The biggest value. Let's see here. So for something of 2. So, okay, so now we can just map the keys to whatever this is, right? So we can just say for ik in enumerate d.keys, then biggest would just be the max of h. If the current value is equal to biggest, then result equals to, well, so we want to line this up with this. So if you look at 6, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, that's why it's -1. So it's the 5th one. So you have to line up this with the keys now. So other is list d.keys. It's kind of confusing. So now IL in enumerate or anything, IP in enumerates other. So if other or if biggest I equals to, sorry, if h of I is equal to the biggest, then we can just return P, right? Because that is just going to line up exactly 6, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So you get that guy. Here it looks correct. So let's submit this. And there you go. So not the most efficient solution, but again, I did come up with this on my own. It's really kind of confusing, and you really just have to sort of make a lot of observations. But again, this is my own solution, not the most efficient, but I think it's not too terrible to understand as long as you get the fact that you have to accumulate the values before trying to find the position of the biggest value in the dictionary and return that corresponding key, then that would make more sense. So thank you for watching. Hope this was helpful. I know it's a bit confusing, but stay tuned for more, and thank you for watching. Take care.